Welcome, everyone. I'm excited to kick off this presentation on Introduction to Identity and Access Management, or IAM for short. Today, we'll explore what IAM is, why it's so crucial in cybersecurity, and what goals it aims to achieve. Over the next few slides, we'll cover how IAM helps protect our data, ensures compliance, and improves overall security and efficiency. So let's get started. Let's start by exploring the basics of IAM, or Identity and Access Management. At its core, IDM, or Identity Management, is all about creating, maintaining, and managing user identities and their attributes within a system. The main goal here is to ensure that only valid users are able to access the system, which helps keep our environment secure. Moving on, Access Management, or AM, focuses on controlling who can access what within these systems. This involves two key processes: authentication, which is how we verify someone's identity, and authorization, which determines what resources they are allowed to access once their identity is confirmed. Finally, there's Privileged Access Management, or PAM. This is a specialized area within IAM that deals specifically with accounts that have elevated or high-level access. These privileged accounts are often critical to system security, so PAM involves managing and monitoring them carefully to prevent misuse or breaches. All these components work together to create a comprehensive security framework, ensuring that only the right people have the right access at the right time, protecting sensitive information and systems from potential threats. Let's take a closer look at Identity Management, or IDM, in more detail. Central to IDM is the concept of Identity Lifecycle Management, which covers the entire journey of a user's digital identity within an organization. First, we have provisioning, or create. This is when we set up a new user account as soon as someone joins the organization. It's about creating that initial identity and making sure they have the right starting access. Next is maintenance, or enable. This step involves updating roles and access permissions as the user's responsibilities evolve or change over time. It's important to keep their access current and aligned with their tasks. Finally, we have deprovisioning, or exit. This is when a user leaves the organization, and we need to quickly and securely remove their access to protect our systems and data. All these phases are interconnected and crucial for maintaining security and operational efficiency. By managing the entire identity lifecycle effectively, organizations can ensure that access is granted appropriately, updated as needed, and revoked promptly when necessary. This comprehensive approach supports the broader goal of secure and seamless identity management across the enterprise. Let's start by talking about password management. It's a critical aspect of our security strategy. We enforce policies like password complexity, meaning passwords need to be strong and difficult to guess. We also set expiration rules, so passwords are changed regularly, and maintain a history to prevent reuse of old passwords. To make this easier for users, we include tools like self-service password resets, which allow users to quickly regain access if they forget their passwords, and password vaults that securely store and manage passwords. Moving on to access certification, this is about regularly reviewing who has access to what. These periodic reviews help us confirm that users only have the rights they need, nothing more, nothing less. It's vital because it helps us identify any excessive or unnecessary privileges that could pose risks if misused or compromised. Finally, let's discuss registration, proofing, and establishing identity. When new users join, we need to verify their identities securely. This can be done through various means, such as checking official documents like IDs, using biometrics like fingerprints or facial recognition, or leveraging external verification services. This process ensures that we confidently establish who our users are right from the start, which is fundamental for maintaining a secure environment. All these elements, password policies, access reviews, and identity proofing, are interconnected. They create a comprehensive framework that helps us protect sensitive information, ensure proper access, and verify user identities, supporting our overall security objectives. Let's talk about directory services. Essentially, This is a centralized repository that stores critical information about users, devices, and permissions across an organization. Think of it as a master directory that keeps everything organized and easily accessible. Some common examples include LDAP, which stands for Lightweight Directory Access Protocol, and Microsoft Active Directory. These are widely used to manage and access directory information efficiently. Now, the core functions of directory services are quite important. First, they handle user authentication and authorization, meaning they verify who you are and what you're allowed to do. This is fundamental for security. Secondly, they help with resource discovery, making it easier to find devices, files, or services within the network. And finally, they enforce policies, ensuring that security rules and permissions are consistently applied across all users and devices. Overall, directory services play a vital role in maintaining a secure, organized, and efficient IT environment, which ties back to our broader theme of managing and protecting digital resources effectively. Let's take a closer look at the different types of application architectures. First, with traditional architecture, applications are hosted on-premise, meaning everything is managed locally within the organization's own data centers. This setup relies heavily on a centralized Active Directory, or AD, for managing identities and access. It's a straightforward approach, but can be less flexible when it comes to scaling or remote access. Now, moving to hybrid architecture, which is quite popular these days. This approach combines on-premise infrastructure with cloud-based services. For example, you might have your AD synchronized with Azure AD, allowing seamless identity management across both environments. It offers a good balance, providing the control of on-premise systems while leveraging the flexibility and scalability of the cloud. Finally, modern architecture takes this even further by being entirely cloud-native. This setup uses microservices and APIs, making applications more modular and easier to update. It also leverages federated identity systems and single sign-on, or SSO, which simplifies user authentication across multiple services. This approach aligns well with the trend toward agility, scalability, and improved user experience in today's digital landscape. Connecting this to our overall theme, understanding these architectures helps us see how organizations can evolve their identity and access management strategies to match their technological infrastructure and business needs. Let's take a closer look at access management components. This slide highlights the key elements that make up an effective access management system. First, we have authentication, which is all about verifying who someone is. Think of it as your digital ID check, using passwords, biometrics, or other methods to confirm identity. Next is authorization, which determines what an authenticated user is allowed to do. It's like setting permissions, what files they can access or actions they can perform. Then, we have user management, which involves creating, updating, and deleting user accounts to keep access current and secure. Lastly, there's access policies, the rules and guidelines that dictate how access is granted or restricted in different scenarios. These components work together to ensure that only the right people can access the right resources, aligning with the overall goal of maintaining security and operational efficiency in our systems. Now, let's continue with access management, focusing on some important factors of authentication. When we talk about authentication, it's crucial to understand that there are different ways to verify someone's identity. One common method is something you know, like a password or a PIN. These are familiar, but they can sometimes be vulnerable if not managed properly. Another factor is something you have, such as an OTP token or a smart card. These add an extra layer of security because possession of the device or card is required to access the system. The third factor is something you are, which involves biometrics like fingerprint scans or face recognition. These are increasingly popular because they're unique to each individual and hard to fake. Moving on, accountability plays a key role in access management. This involves maintaining audit logs that record actions performed by users. These logs are essential for tracking activity and ensuring accountability. They help us trace access and identify any suspicious or unauthorized behavior. Finally, session management is about controlling user sessions effectively. For example, automatic session timeouts can log users out after a period of inactivity, reducing the risk if a device is left unattended. Reauthentication prompts are another safeguard, requiring users to verify their identity again before performing sensitive actions. All of these components work together to create a robust access management system, one that not only verifies identities, but also ensures accountability and minimizes security risks. This is fundamental to maintaining a secure and trustworthy environment in any organization. Let's take a closer look at single-factor versus multi-factor authentication, or MFA. On this table, we can see the key differences. First, the definition. Single-factor authentication, or SFA, relies on just one element, usually a password. In contrast, MFA uses two or more independent factors to verify your identity. When we talk about the factors involved, SFA typically depends on something you know, like a password. MFA, however, combines multiple factors such as something you know, like a password, something you have, such as a one-time password sent to your phone or a smart card, and something you are, like biometric data, your fingerprint or facial recognition. Now, regarding security levels, SFA generally offers a lower level of protection because it's vulnerable to attacks like brute force, phishing, or keylogging. MFA provides a much higher level of security because even if one factor is compromised, the other factors still help protect your account. In terms of user experience, SFA is quick and simple, just a username and password and you're in. MFA might add a few extra steps, perhaps entering a code or performing a biometric scan, but these are worth the added security. Looking at examples, SFA would be something like logging in with just a username and password. MFA, on the other hand, might involve entering a password plus a one-time code sent to your mobile, or using biometric authentication like fingerprint scanning. As for common usage, SFA is often found in legacy systems or non-sensitive accounts where convenience is prioritized. MFA is more common in sensitive areas, banking, corporate systems, cloud services, or healthcare, where security is critical. Finally, when it comes to attack resistance, SFA is weaker against phishing, password reuse, and credential stuffing. MFA offers stronger resistance, making unauthorized access and identity theft much more difficult. However, implementing MFA tends to be more costly and complex, though it's becoming increasingly standardized across many platforms. So, in summary, understanding these differences helps us choose the right approach depending on the level of security needed and the context of use. Microsoft Active Directory, or AD, is a directory service developed by Microsoft that plays a crucial role in managing users and computers within a Windows domain environment. Think of it as the digital phone book for your network, where all the identities and resources are organized and accessible. It was first introduced with Windows Server 2000, marking a significant step forward in enterprise identity management. In terms of its role in IDAM, identity and access management, Active Directory serves as the central hub for managing identities. Instead of juggling multiple systems, AD consolidates user and computer information in one place, making administration much more efficient. It provides authentication services, ensuring that the right people are who they claim to be, and authorization services, determining what resources they can access. Additionally, AD helps enforce policies across the network through group policy. This means administrators can set rules and configurations that automatically apply to users and computers, maintaining security and consistency throughout the organization. Overall, Active Directory is fundamental in creating a secure, organized, and manageable network environment, aligning perfectly with our theme of effective identity management. Now, let's take a closer look at some key components within Active Directory, starting with domain controllers. These are essentially servers that handle security authentication requests, such as when users log in or permissions need to be checked. They also maintain the Active Directory database, which is crucial for storing all the object information and ensuring everything runs smoothly. Next, we have organizational units, or OUs. Think of these as logical containers that help us group users, groups, and computers in a way that makes management easier. They also enable delegation of administrative control, meaning we can assign specific management rights to different parts of the organization without giving full access to everything. Finally, let's discuss domains. These are the fundamental building blocks of Active Directory. Domains define administrative boundaries and serve as the containers where data about objects, such as users, computers, and resources, is stored. They help organize and secure our network environment, making sure everything is structured and manageable. Together, these components form the backbone of Active Directory, helping us manage and secure our network efficiently while supporting organizational growth and flexibility. Let's talk about forests in Active Directory. A forest is essentially a collection of one or more domain trees that share a common schema and global catalog. This shared schema defines the structure of the directory, including the objects and attributes, ensuring consistency across the entire forest. The global catalog helps with efficient searching across the forest. Now, the structure and hierarchy within a forest follow a specific order. It starts with the forest itself, then branches out into multiple trees, and within those trees are the individual domains. It's important to note that a single forest can contain multiple domain trees, allowing for flexibility in how your organization is structured. Trust relationships are another key concept. These are established links that enable users in one domain to access resources in another domain within the same forest. Essentially, trust relationships facilitate resource sharing and collaboration across different parts of your organization, which ties back to the overall goal of Active Directory: centralized management and seamless access. Understanding these elements helps us see how Active Directory supports complex organizational structures while maintaining security and ease of management. Now, let's talk about Group Policy Objects, or GPOs for short. These are a key feature of Active Directory that we use to control the environment of both users and computers. Essentially, GPOs help us manage and enforce consistent settings across our network. Some of their main functions include enforcing security settings, which is crucial for protecting our systems. They also allow us to deploy software efficiently, ensuring that users have the tools they need. Additionally, GPOs can execute scripts at startup or shutdown, automating important tasks and maintaining smooth operations. GPOs can be applied at different levels: site, domain, and organizational unit, or OU. This layered approach gives us flexibility. We can set policies broadly or target specific groups of users or computers depending on our needs. Overall, GPOs are a powerful way to manage our IT environment, ensuring security, consistency, and efficiency across the entire network. Now, let's take a closer look at the differences between Active Directory and Azure Active Directory. Starting with deployment, Active Directory is traditionally on-premise, meaning it's hosted within your local network infrastructure. In contrast, Azure AD is cloud-based, which provides greater flexibility and scalability for modern organizations. When it comes to protocols, Active Directory primarily uses LDAP and Kerberos for authentication and resource access, which are well-established standards for Windows environments. Azure AD, however, relies on modern protocols like OAuth, SAML, and OpenID Connect, making it more suitable for cloud applications and web-based services. In terms of resource access, Active Directory mainly manages Windows-based resources, such as file shares and printers. Azure AD, on the other hand, is designed to handle access to cloud applications like Microsoft 365 and various SaaS solutions. Regarding group policies, Active Directory supports group policy objects, which allow centralized management of user and device settings within a Windows environment. Azure AD doesn't support group policy directly, but uses conditional access policies to control access based on various conditions, enhancing security in cloud scenarios. For authentication, Active Directory relies on Windows login credentials, integrating seamlessly with Windows devices. Azure AD offers web-based login options, enabling users to authenticate securely from any device with internet access. When it comes to trusts, Active Directory supports trust relationships between different domains or forests, facilitating resource sharing across organizational boundaries. Azure AD doesn't support trusts in the traditional sense because it's a cloud service designed to work with multiple tenants without direct trust relationships. Finally, device management in Active Directory is handled through group policy objects, allowing detailed control over device configurations. Azure AD leverages services like Intune and conditional access for managing devices, especially in mobile and remote work scenarios, providing a more flexible and modern approach. Overall, understanding these key differences helps us choose the right identity and access management solutions tailored to our organizational needs, whether on-premise or cloud-based.